Okay, this is the lesson or the teaching or the reteaching or however you want to look at it for the Unit 3 FIF4 summative assessment. And it is very similar to the FIF4 from Unit 2. However, this one has to deal with cubic functions. In fact, there are 4 specific things that you're going to have to do. 4 of the key features that you're going to have to look at for the cubic functions. We have local max and min. We have intercepts. We have end behavior and domain and range. And then there are a couple different things to get from it. I just wanted to go over some basics of what cubic functions are before we start into everything because it'll make more sense. So first of all, cubic function is a function that has an x to the third in it. Like that's the highest power is that of the function has a cube, like 3. That's a cube because it would be like 3 dimensions. Length times width times height would be the volume of a cube. All right. And then this is kind of an example. This is just an example of a cubic graph. Technically, we could have a couple different things. One of the cubic graphs could be like kind of like this, where there's nothing like peaking up or down with it. We have this one where it's only crossing the x-axis once. You could have things like this where it crosses it 3 times. A maximum of 3 times is as many times it could cross. You could have it where it crosses here, comes down and touches, and goes up. And all of these 4 that I just drew were positive x cubes. So all of these are positive x cubes. There could be numbers in front to make them skinnier or taller or more extreme in like their max or min, their local max or min. But this is the general idea. While on the other hand, there could be negative versions of those. So it's basically the same thing. You could have being above like this. It could be just not really having any extreme local max or min. It could be like this where it crosses 3 times. It could be where it comes down, crosses here, and then touches once there. Like there are all sorts of options for it. But that's going to help us with the idea of all of these topics. So a local max or a min. So a max is the local greatest value of the function. And that with these, if you're looking at these tables, it would be like the highest, the local biggest value of that. Like the other numbers around it are less than that. And then the minimum would be, this is the numbers around it would be greater than that. So local least value of the function. So an example. So I'm going to do this in, I'll do this in this color. So a local max or a min is that point or that point. This one has none. I'm just going to put no. There's a local min. There's a local max. Local min, local max. Local max, local min. Max, min, none. That's what that is. Intercepts are the same thing that you've done for like your whole life as far as you've been graphing and everything. I'm going to change the color on this one. Intercepts are where it crosses the x. So there are x intercepts and then there are y-x intercepts. So this is an intercept. That's an intercept. Intercept, intercept, intercept. This one would have a total of 4 if you include the y. This one probably just has 1 if I drew it nice, especially. Intercept there and there only has 1 if I drew it nice. This would have 3, 4 I mean again. Oh, not that one up there at the top. Oh, undo. That one right there, 3 if I drew it nice. And this one would have 3 because there'd be the y. So 2x and then 1 y. End behavior, this looks like the most confusing part, but I like drawing these big general things because the end behavior always follows whether they're positive or negative. I call this, when we're doing the cubics, I call it the disco. Because you'll notice I'm going to make this a person with arms and they're doing the disco, pointing up and pointing down. So this person, again, this is a positive person. There's their arms and then there's the legs. They're pointing up and pointing down, right? So positive means that like going from left to right, this points down, that points up. If it was negative, then it goes the other way. So here's my person, comes down. So they're basically, that person's right hand goes up, and their left hand goes down if you were looking at them. So like that. Then here we have this person. Here's their thing, their graph. Does that make sense? So here's their face, and you're looking at how they're dancing. So this is positive. I'm positive. Down on the left. So the left goes down, and the right goes up. While with these, it's the opposite. So this is the left goes up, and right goes down. Left is up, right goes down. Okay. And then domain and range for all, it's going to be all real x's and y's. So that's all you have to know really about that one. Okay, so let's do this. And then there are 3 different things that you can do it from. The hardest one by far for me is the table. Then we have from a function, and then from a graph. The graph is way for sure my favorite because you can see it and you can look at it and you can be like, oh, that's what it does. And so I'm going to put hearts by this, and we're going to do one of them. Let's just say that you were given a function like this. So maybe we had f of x equaled. So there are a couple different ways it could do this. Main thing that you want. So let me do x minus 3 multiplied by x plus 1 multiplied by x plus 4. If we were to graph this one, before we even graph it, we can see that we have 3 x's here. 1, 2, 3. So I know it's going to be cubic. Also, I noticed that it is positive. So before I even graph this, actually, I'm going to come over here because this is kind of where it fits better. I don't even have to graph it. Oh, that did not go over nice. I'm going to stop that. I don't even have to graph it for this for me to get a lot of information for it. So first of all, it's positive because there's nothing in front of it right there, like positive. So I know it's going to follow this guy. The left side is going to be down. It's going to be left, down, right, up. And this is how we write that. As x goes to negative infinity, f of x goes to negative infinity. And then as x goes to positive infinity, because that means right, then to say up, we say f of x goes to positive infinity. So the normal one, when it's positive, they're like, this is negative. It goes negative, 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 and positive, positive. If it goes the other way, like if it's a negative thing, then they're opposites. So left goes positive, right goes left goes positive, right goes negative. So yeah, normal one, they match. Negative one, they're opposites. Okay, so we already have that about that. I'm gonna I do want to switch this over to the thing because we're talking about the function. I just need to cut it better. And now I'm gonna move that over here. Oh, good. But if you want to see that, you can. So we have x subtract 3, x plus 4. So you go into Desmos and you can graph it. So we had parentheses, x, let me make sure what it was, subtract 3. Yep. Okay. X subtract 3, x plus, what was it? 1 and x plus 4. X plus 1, oops, 1 and x plus 4. So this Desmos app, let me zoom out on it a little bit here and then you can see it better. This Desmos app is free and you can just go onto the computer and get it, or you can download it, whatever. But from here, you have so much information. Once we graph it, we can get all the information we need. So if I zoomed out, I can see that the left side is indeed going down. The right side is going up. So we already talked about the end behavior. That's that. Then each one of these factors, the x subtract 3, x plus 1, and x plus 4, each one of those factors corresponds with a 0 of the function or an intercept of the function. I can even tap on my graph here, and I can see that there's one at -4, -1, and 3. You'll notice here in our function, we had x subtract 3, and notice we have a 0 at +3. Our factor on the left was x plus 1, and we have a 0 or a 0 on the x-axis or the intercept at -1. So +1 went with -1, and then we have x plus 4 went with -4. Then the other one that we would need to get is the y-intercept, and you can just again tap on there and get that y-intercept. So that was at -12. So let me come in here and write those things down for the intercepts. We had from the +3, we had one at 3, 0. From +1, we had it at -1, 0. And from +4, we had one at -4, 0. And then on our graph, these are the x-intercepts. And our y-intercept, when we clicked on it, it was 0, -12. Oops, 12. Okay. Next thing that we needed, we talked about end behavior. Oh, we got all those intercepts. Okay, now we need local max or min. So again, coming to the graph, click on the top. That's a local max, and that's at a weird spot. Local min, that's at a weird spot. Now, what they'll do with these things is they'll say it's in an interval. So I would know on this graph that the maximum happens somewhere between -1 and in the interval. Let me zoom in a little bit on this graph so it'll make more sense. I think those each go by 2s. So this max goes in between, and look at the x-axis, is somewhere between -2 and -3. That's what I would say. So a local max at -2.94, I think is what it was. Is that what it was? 694 and 12.597. So 694 and 12.597. And then local min is at, so I take the graph, maybe. Okay, there we go. Down here. And 1.3 basically, and -20 point something. 1.3 and -20 point something. Because you don't have to have exact. Basically, you need to be able to identify it. So I graphed it. Let me just draw a quick picture. I have a point at -4. 1, 2, 3, 4. So it crossed right there and over at 3 and down at 12. And it was like really big. Oops. Like this. So I graphed it. From a graph, it's pretty easy. You can see it. You can also, what you're mostly going to have to do in the problem with the graph is they're going to give you a function and they'll say which one does this match. They'll give you a table and they say which one does this match. So look at your table. Does it match the graph? It's probably the easiest problem. So now I'm going to come to the table. So these table ones, I think, are definitely the hardest part. But let me start with what the parts that I think are the easiest. First of all, I think the easiest are the intercepts. Remember that our x-intercepts are when we have a number, 0, and our y-intercept, and there might be more than one, there could be up to 3. Our y-intercept would only have 1, and it's 0, something. So you can look at the table, and I can see that this is an x-intercept. So it's at -1, 0. And then this right here is my y-intercept. It's 0, 1. And the table doesn't have anything else. The next part, so we have intercepts. I think that's the easiest. The next easiest for me is the end behavior. So when we're talking about left and down, technically the left is the negative x's. And so here are our negative x's. This is the left side. What's happening with these numbers? Well, let's see. They're going -1, -8. Looks to me like they're going further into the negatives, and so it goes down. So left negatives, negative x's means negative f of x, which means down. So we'd go as x goes to -infinity, f of x also goes to -infinity. And then the other one would have to be the positive. So as, and let's make sure. Here's my right. And then right there, that's going up. As x goes to +infinity, f of x also goes to +infinity. So we have the x-intercepts, we have the end behavior, the x and y-intercepts, the end behavior. The next thing is going to have to be the local max or min. And if I look at these numbers, it doesn't look to me like anything is going to be changing. This is how I can double check. So let me do this with yellow. This is kind of, I'm sorry that I'm writing all over this, but this is what works. I start going down the f of x's and I see if it's going up or down. So I can see from -8 to -1, that's going up. From -1 to 0, that's also going up. And then it changes, and then, and then it still goes up. 0 to 1 goes up. 1 to 8 goes up. 8 to 27 goes up. So there's no max or min, no local max or min. So that's what you do for those. And the domain and range with all of them is all reals. Okay, but if we have something, a more complicated table like this, let's go through and do all the things that we just did on the other one with this one. So let's start with our intercepts, because that is, in my opinion, the easiest part. So intercepts. We're looking for all the times that we see 0. So there's a 0, there's a 0, there's a 0, there's a 0. Nice. So when there's a number, when we have those zeros, when there's a number on the left side, those are the x-intercepts. So our x-intercepts are at -1, 0, 1, 0, and 2, 0. Okay. Y-intercept is the one where the 0 is in the x spot, and that's going to be 0, 2. Not too bad. Then we're going to do our end behavior. And behavior. So again, this is the left side. If we look at these numbers, that looks to me like they're going further into the negatives, and so that's going down. And then this is going to be the right side. As we look at those numbers, they're going up. So it's the same. So as x goes to -infinity, f of x also goes to -infinity because it's going down. And then as x goes to +infinity, and usually they don't put the positive there, by the way, f of x goes to +infinity. All right, so we got that. Last part is the local max or min. Max or min. So I'm gonna go through all of these numbers between -40 and -12. I went up, 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 still going up, and right there up. Ooh, but then right here it's changing, and now it's gonna go down. Between 2 and 1 point something, it's going down. Between there and there, it's going down again. Between there and there, going down. And then right there again, it's changing, and now it's going up and up. So these places where I can see it changes, that's when we are going to have a local max or a min. If you're going up and changing to down, that's on the graph. It's like it's going up and changing to down. So we have a max. And the max is going to be somewhere in this change. So like somewhere between -5 and 0.5. This is going to be a max somewhere in there. And then again, where it changes, it's going down and then it comes back up. That's going to be a min. So somewhere between 1 and 2, there's going to be a min. So it will say a range, a max in the interval of, I'll just make it a little bit bigger, -1 to 1, and then a min in 1 to 2. Whew. Okay, that is what you have to do for that whole thing. And on a graph, you just look at the table. So that is FIF 4 for cubic functions.